Welcome back. In our previous section, we talked about creating outstanding maps. In this section, we're going to address the topic of network graphs and how we can build powerful network graphs to display connected data sets. So this section will cover how we can begin building and creating exceptional network graphs, and the goal here is to display connected data sets. So data sets where there are linkages between people, places, or things. And what we're going to cover in the following videos, we'll start with an introduction, brief overview of graph theory and some tools. Then we'll look at securing or creating some data so we can begin building our graph. We'll follow that by actually starting to build some network graphs and designing and optimizing them. The following video will talk about graph metrics, some different statistical measures that we can use to help inform our design decisions. And then we'll have two videos that focus on styling, one with size and one with color, much as we saw with maps or graphs, traditional charts. Using sizes and colors for maximum impact can really set a visualization apart. And we'll conclude this section by a talk on how we can share our graphs. So, real brief overview of network graphs. We use them for the display of connected data. And as I mentioned, connected data would be data sets where we've got linkages between people, places, things, events, and so on. In any scenario you can think of where there are connections is a suitable target for a network graph. Typically, when we're talking about network graph data sets, we're talking in terms of nodes, otherwise known as entities or vertices, and edges, which would be the connections or links between nodes. And there are a variety of purposes. This is a very brief summary of them. Social network analysis, also known as SNA, it's a very common use case. People looking at Twitter or Facebook or LinkedIn networks. And there are also some very serious uses, tracking disease transmission, for example, or crime tracking patterns. And we've got a number of tools at our disposal to create and analyze within the software, including Gephi and Cytoscape in the open space. And then there are a variety of R and Python packages and numerous proprietary software apps as well. So with that brief summary, let's take a look at how we can create our own network data or some locations where we can acquire existing network data. And why should we want to create our own data? Or secondly, locate existing data? And my short answer is this is a very fascinating space, and you'd want to have this as part of your data visualization capabilities because it serves a need that traditional chart or display capabilities don't. So dashboards, charts, bar charts, line charts, etc., don't typically deal with the connectedness of data in the way a network graph would. And to create these data sets so we can begin building the graphs is a relatively simple process. There's a little bit of a learning curve, but all we need to wind up with is a data set with nodes and edges. And if you're looking for existing network data sets, the sources out there are small relative to other data file types, but it is steadily growing, and there's enough out there to get you started. And as I mentioned earlier, and we'll touch on frequently in this section, network data and network graphs really uniquely allow for visual exploration of relationships and structure within a data set. So to summarize why we should spend time creating network data, number one, we can't do a network graph without a network data set, so it's one has to precede the other. And the good news is we can create these using spreadsheet or database software or R or Python, whatever your tool of choice is. But the bottom line to it is that it allows us to really create some fascinating, informative graphs that tell compelling visual stories. So I mentioned you can use spreadsheet software such as Excel to create your own basic node and edge files that you can then export for use in a tool such as Gephi. And here I've got a very simple data set showing State of the Union speeches by presidents and concatenated with the year they delivered the speech and how many keywords. This was a text analysis project. And all I'm trying to do is take this data that I've put in a pivot table and wind up outputting it into a node file where I've got every mention of every word or phrase. And by the way, I later truncated this to words rather than phrases, make it less complex. And then edges. So we want to know who said what. So the fact that President Washington in 1790, which words did he use? And then President Adams in 1797, which words did he use? And then we've got these connections or linkages from people to phrases that they use. And that's the crux of a network data set. In similar fashion, I use MySQL code in a somewhat more complex example, and we'll see the trade network later in this section that I wound up creating out of this code. But we're doing the same sort of thing where we're creating sources and targets, and we're using case statements to pull this all together. And that's going to then be able to feed into our software and be interpreted as graph data. And then if you'd rather start with some existing examples, the Stanford SNAP project has got a collection of different large networks, and this might also lead you into some different areas, some different resources that also house network data that you can begin building with. So to summarize, network data sets, as we saw, we can create our own using spreadsheets or database software, among other approaches. If you're an R or Python whiz, certainly you can do it out there. And you can find, even though the resources are thinner than for other types of data sets, there are still many interesting data sets to be found on the web. And then once we've got a connected data set, the visualization possibilities seem almost limitless. And that's where it gets really fun when we begin building from the data.